The broadcast is now starting. All attendees are in listen-only mode.
Well, hello everyone, and welcome again to another ATRA webinar. Today's presentation is sponsored by Seal Aftermarket Products. We'd like to thank them for making the webinar free and available to everyone as far as members and also non-members of ATRA. Today's presentation will be a little bit different. We've been provided with a short video from Seal Aftermarket Products. We're going to show you that in a moment. I would like to mention also that we would like to have some feedback from you guys as far as what you think of having some short videos put in some of the webinars coming up in the future to enhance some of the tech that we've been trying to present in our webinars.
Seal Aftermarket Products engineers and manufactures Toledo Transkit with the rebuilder in mind, including everything you need to get the job done right. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment, plus all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. At Seal Aftermarket Products, we don't just make kits, we make kits better. Ask for Toledo Transkit by name.
Okay, now I'd like to mention one more thing. The ATRA Expo is coming up real soon, and if you'd like to go to your app store, if you have a smartphone, just type in ATRA and type in ATRA Expo, and you can download the app for free. The app works pretty neat. As you can see here, once the app's installed, you can actually look at the trade show floor plan and see where the vendors are actually located. Kind of makes it easier for you to maneuver around the trade floor. One of the features that I think is really cool about the app is you can click in on the management or technical seminars. You can see the actual speakers that are speaking in those seminars. And if you click on the speaker's name, you'll actually get a short bio of the speaker himself and also what he's presenting in his particular seminar. So it's a pretty neat app. Like I said, it's free. Only takes a few seconds to download it to your phone, and it works out pretty good. Today's presentation, we're going to be talking about the Allison LCT1000. Now, we have had some past webinars on the Generation 2 and Generation 3 updates. We've gone into a little more in-depth information on changes of parts of what will retrofit back to earlier models. What I want to do today is just kind of go over an overall of all three generations and kind of go over some questions and things that we've been getting asked on the tech line. Any questions or comments, send your emails to webinars@atra.com. Especially some feedback is on how you guys feel about us putting some more short videos in the webinars. If you have any questions during the webinar, please feel free to text them to me. I will try to answer them the best that I can, and you can just text them anytime during the webinar itself. First thing I want to talk about is the differences between the three generations. Allison came out approximately about 2000 to 2005. It's a 5-speed. Sometime in mid-2004, the G solenoid was added to actually lower line pressure. These transmissions work on full line. So this solenoid was added in 2004 to lower line pressure when it's in park or neutral, basically when the vehicle is standing still. The main complaint that the solenoid was installed for was pump line complaints. The manufacturers at the dealer level were getting a lot of complaints, especially on gas vehicles, which run much quieter than the diesels. These guys were complaining about pump line. Well, the unit's working on full line pressure, you're going to have some type of pump line. There's been many updates done to the pump to try to fix that concern. from 2000 up to 2004. Then they added the G solenoid to basically just lower the line pressure when the vehicle is not being used. In 2006 to 09, Generation 2 came out, and that's when Allison became an actual 6-speed. Also in 2006, the trim solenoids were actually changed, or they're referred to as pressure control solenoids. The neutral start backup switch, or rain sensor, whichever you want to call it, was then actually put inside the transmission and became an internal mode switch. 2010 to 2013, Generation 3 came out. Allison was still a 6-speed, but one of the major changes here was the G solenoid was eliminated, and they actually fitted it with a main modulator solenoid. Now this actually controls line pressure like a transmission that we're normally used to dealing with. So they're no longer working it on full line. They're actually controlling line rise through this solenoid. In 2014, Generation 4 has come out, and it's now become an 8-speed transmission. Now, obviously, along with these changes, there's many changes to the internal components. Some of these components can be interchanged to earlier vehicles, and some cannot. Some can be interchanged as complete assemblies, and we're going to kind of go through that as we go through the webinar. This is the ID tag located on the passenger side towards the rear of the case, just behind the PTO cover. It gives you the date of manufacturer, obviously the transmission ID number, and engineering feature configuration number and serial number of the transmission. This is really going to help, especially when it comes to ordering parts. So if you go to your Allison supplier, they may ask you for the information off this tag to help identify what they need to send you. This is a cutaway view of the transmission. As you can see, we have 5 clutches in here, no sprags. So this is a clutch-on-clutch application. So it's really important to make sure that you keep your end plays to at least factory specs. And also the solenoids and valve body is going to have to really be working correctly, especially as far as keeping them clean. Solenoids have to work properly. Obviously with a clutch-on-clutch application, we don't have any sprags or anything to freewheel, so all these things are going to become a little bit more critical. Here's the 5 and 6-speed apply chart. As you can see here, to make this a 6-speed, they basically drop the C3 clutch, and they reapply the C4 clutch. So as of 2006, when it became a 6-speed, they just basically fire the solenoids differently and bring the clutch packs on differently and get a 6 ratio out of it. I'd like to cover a little bit about the speed sensors. There's 3 speed sensors on the transmission itself. As you can see in the front, we have an engine speed sensor, a turbine speed sensor, and an output speed sensor will be located where you see here if this was a 2-wheel drive extension housing. Obviously, we're using a 4-wheel drive case here, so the output speed sensor in that case would be actually located on the transfer case itself. Now, the 3 speed sensors are AC pulse generators. They produce their own AC voltage from about 150 millivolts to about 15 volts, depending upon RPM. Now, the wiring to these sensors have shielded grounds going to them to help prevent any EMI issues, electromagnetic interference. We do see a lot of problems with the harnesses along the top of the case where the wiring gets very brittle and they break. And we also see areas where they rub through. Now, a little bit about the engine speed sensor. It's actually monitoring the dimples on the torque converter itself. And the gap between the sensor and those dimples are about 33 thousandths. Now, it's real critical to make sure that these dimples aren't damaged like you see the one here on the right. This particular torque converter actually caused TCC surging, engine surging, and there were no codes stored anywhere. We got the call on it, and we even took the scan tool data and went to grafting mode, took snapshots, and still couldn't find the glitch. It wasn't until we actually put an oscilloscope on the sensor itself, and every once in a while you could see a slight glitch in the pattern, the wave pattern that was going by, and that's how we discovered the issue with the dimples on the torque converter. Good point is, in 2007, apparently the manufacturer felt there was no need for it, maybe due to issues with, complaints on warranty, whatever. They've eliminated it in 2007. So everything 2008 and later, that sensor won't be there. The turbine speed sensor, the one that's located just above the PTO cover, it's actually monitoring the teeth, as you see here on the PTO drive gear. That's attached to the C1, C2 clutch drum. Again, output speed sensor will be located there on the tail housing if this was two-wheel drive, and for four-wheel drive it's located on the transfer case. A quick look here at the valve body. This is a 2003 valve body. We have 3 shift solenoids that are normally closed. We have 2 trim solenoids. Trim solenoid A is normally closed. Trim solenoid B is normally open. One thing I'd like to mention for any of you guys out there that are working on the Asian Seiki, the AS68RC, the linear solenoids on that transmission are part of the valve body. In other words, you can't buy those separately. And if you have to purchase the valve body, I've seen them go for as high as $3,500. Now, the on and off solenoids and the pressure switches can actually be bought separately. Now, the Allison trim solenoid B, being that it's normally open, can actually work in place of one of these linear type solenoids found on this unit. So the trim solenoid B is approximately 120 bucks. So before you go out and spend $3,500 for a valve body because you need linear solenoids, you can at least purchase the trim solenoid B from an Allison and use it on the AS68RC. This is the other side of the valve body, the shift valve body. This is where shift solenoid C is located. Again, it's just like the other shift solenoids, it's normally closed. This is 2004 to 05. This is when the G solenoid was added. And remember, like we were talking about before, it was to help reduce line pressure at a standstill to prevent pump noise. Now, this is the earlier version of it. And as you can see, this housing, the area that we're pointing at here, is blocked off. There's no hole there. You have to be careful when you're interchanging parts, and you'll see in a moment why we're pointing this out. Obviously, when this change came along, the internal harness changed. The TCM added a pin and a driver for that solenoid. Here's a quick look at the changes in the separator plate from 03 to 04. And this again is the one from 04 to 05 on the right. In 2006, as I mentioned before, the pressure control solenoid A and B, what was usually called the trim solenoids, these are now pressure control solenoids. And as you see here in 2006, we still have the G solenoid, which is pulse width modulated, but in 06 they actually added a tube feed to that solenoid. So if you happen to go through some cores and you grab the housing and the solenoid out of an 06, you don't want to use that on an 05 or earlier. Obviously, you would have a tremendous leak in the hydraulics here. When this change came about, obviously there was some hydraulic changes also to this valve body because of this tube being added. There's a few other changes made in 2006. Like I said earlier, we did do some webinars earlier on the Generation 2 and the Generation 3, a little more in-depth as far as all the parts that were changed. These are some of the most common parts that were changed over in 2006. On the left, you have the name of the part, you have the previous part number, and the 06 and up later part number also listed there. 2010, things got a little bit different. First thing they did was eliminate the G solenoid. They now have a main modulating solenoid. Now this one actually controls line pressure just like a transmission that we're used to before this. So now we're controlling line rise with the solenoid, and we're not just dropping pressure at a standstill. We're controlling line rise in all the different modes of operation on the transmission. One of the things you have to be careful of, as you can see here, there's a solenoid retainer bracket that actually holds the solenoid in place correctly, and you don't want to put it with it facing up. It has to face down like you see on the left, As you can see on the right, this is the retainer installed incorrectly. This is wrong. You don't want to put the retainer on this in that direction. I want to talk a little bit about trim solenoid operation, how these solenoids actually operate. The two trim solenoids are basically controlling the apply of the oncoming and releasing clutch. They also control the holding pressure of all 5 clutches once the shift is complete. Now, the trim solenoids are actually referred to as pressure proportion to current solenoids, or PPC solenoids. The hydraulic pressure provided to the solenoids is proportional to the amount of current being commanded to them. Both the trim solenoids work on a frequency of about 1,000 hertz. The trim solenoid A, although normally closed, actually supplies 86 psi with no current and no trim pressure at full current. This solenoid is also used for fail-safe in case there's any type of a code or loss of power to the TCM. So that solenoid is crucial to fail-safe operation. Now, trim solenoid B is normally open. Obviously, it supplies no pressure with low current. Here we have the TCC and the shift solenoids. The TCC solenoid is normally closed. It is a pulse width modulated solenoid operating on about 100 hertz during the shift. The percentage time of the solenoid, the on time, is referred to as the actual duty cycle. Now, shift solenoids C, D, and E are normally closed solenoids. They supply full line pressure when on and exhaust line pressure when they're off. Now, each solenoid has a shift valve that goes to it. So you have shift solenoid C, D, and E, along with a shift valve C, D, and E also. Now, one of the things I want to mention here on the pressure switch assembly, this manifold is not like what we're used to using or dealing with on like a 4L60 or a 4L80, 4T65. All the previous GM units, the pressure switch actually monitors manual valve movement. Now, manual valve movement on this one still affects the pressure switches, but the actual pressure switches on this manifold are actually monitoring the shift signal. So each shift signal, C, D, and E, is monitored by its own pressure switch. The shift valve pressure switches are all normally open. We have the temp sensor located there also, and we do have a pressure switch for reverse, which is normally closed. You can see the earlier version of this. They had 2 pressure switches on it that weren't used. Later on in 2010, they actually eliminated them, as you can see on the picture on the right. These are the codes you'll find associated with the pressure switches. Now, one of the things that guys seem to jump the gun is when they see a pressure switch code, the first thing they want to do is replace the pressure switch. These codes can be caused by a number of things. Obviously, if the pressure switch itself is not working, and when the computer commands a particular shift and the switch doesn't work, it's going to pop out one of these codes. One of the things we have to remember, obviously, if we have any faults to the clutch circuit itself, valve body issues with valves sticking, or even if the shift solenoids themselves are mechanically not working and not even setting codes, could also cause these 3 codes for the pressure switches. To me, the easiest way to check this, basically hook your scan tool to it, key on, engine off, go to your data stream for the pressure switches, and drop the pin and just basically hang the pressure switch down, still connected to the vehicle, and then just press in and out on the pressure switches and watch the pressure switch state change on the scan tool data. It's also another good time that you can actually go in and air check the clutches. One of the things I want to mention also is this valve body is very sensitive to debris. These valves get easily stuck, and we're going to talk about the one most popular code that I get for a valve being stuck a little bit later on. These units have magnets in the pan and also on the spin-on filter. It's important to clean those, put them back, make sure we flat sand everything on the valve body in the case, and torque everything down the way it's supposed to be. This is what I was talking about earlier. There's your pressure switch logic that you would find on the scan tool. Obviously, we need a scan tool that'll give us, that's capable of giving us this data. But that's the easiest way to go in there and check it. A little bit here about the neutral start backup switch, or what they call the NSBU switch. This switch has given us a lot of issues over the years with this unit. Wrong gear starts, no backup lights, setting codes. A lot of this is contributed to the fact that these vehicles are used a lot off-road and construction sites. They get a lot of mud, water, snow, and stuff in the actual connections. One of the first updates they did was they added an inside seal, as you can see here on the right, and they also added a plastic outer weather shield. They changed the color of the sensor so it's easier to identify it. Those are the first major changes we saw here. Now, they also have repair pigtail harnesses, one for the 7-pin and one for the 4-pin. They come with heat shrink connectors and all that, and you have the part numbers listed there in your handout. What's strange, though, is these harnesses come with the wires all being the same color. They're all white. So you need to use the old connector to match up the pins when you actually change these harnesses over. Later on, around 2004, they did come out with a different switch. They actually call it a PNBU, which is a part neutral backup switch. And that one is black like the earlier ones, and they still have the plastic outer shield, but they went to a single connector. So there's a big change there. 2006, they decided to go with an internal mode switch, so now they moved the sensor inside the transmission. One of the things that I want to point out here is to diagnose this switch, you're going to need a scan tool that's capable of giving you this data information. Okay, I see we've got a question. The question from Derek is, will the pigtail harness kits work on 4L60E applications also? Derek, that's a real good question, and yes, they will. The same switch was used on the 4L60s and I believe also on the 4L80s. But don't quote me on that. I do know they definitely fit the 4L60E. Good question. Okay, getting back to the internal mode switch, again, you need a scan tool. Now we can go in and move the shifter and see if the sequence is working correctly on the scan data. Just want to point out that there's a pin. I don't have it illustrated in this picture, but there's an actual pin that holds that manual shaft in place. And we want to make sure that when we reinstall that the pin actually sticks up about 335 to 354 thousandths of an inch above the surface. Now, we give you a listed number here for the actual tool for that. Obviously, you can use whatever you want in the shop as long as we have something that that can take the pin out. And the important part is the height of the pin when it goes back in. So on the left, we take you through the procedure of how to remove that. Just reverse that and go back in with it. This is the main valve body that you'll find on the 2000-2009. First thing you'll notice is there's no check balls. We have all the spring dimensions listed in the handout for you. We have the legend to identify all the valves. And you'll notice down here in the left corner at the bottom, there's 2 accumulators in this valve body. One thing I want to point out, we've run into this before on the other side of the valve body. What I'm talking about here is the screen that you see with the arrow pointing to the location that it goes to. I had a vehicle called into me that was several miles from a shop here in Florida, and when the vehicle quit moving, the first thing he noticed where the Prindle lights were, it would say shift inhibited. Now, your first reaction was to put a scan tool on it and look at the data stream and see if there's any codes. Now, this vehicle was stuck in neutral. It was basically defaulted to neutral. Even disconnecting the harness didn't help it engage. It would stay in neutral. So when they put the scan tool on it, there were no codes stored, and the range signal looked correct on the scan tool data. Again, shift inhibited does not mean that it's something with the shifter itself. It's just the computer's way of letting the driver know that at this point we're going to be in neutral and we're not going anywhere because we're just going to inhibit any shift you attempt to make. It's kind of a crappy way to do it, but that's Allison's fail-safe feature. Now, what we found was we took someone took the unit out and went through it, couldn't find anything wrong internally. They changed all the electronics on it, and it still didn't move. When the guy took it to the dealer, he was told at the dealership that it was $6,000 for a reman and there was a 6-month wait. Basically, we ended up towing it down to South Florida. It cost quite a bit of money, but we towed it down. And what I did was I had them remove the valve body. I found that screen restricted with a lot of debris in it. And even though the transmission was pretty much cherry, there was enough debris in that screen to cut off the oil to all the solenoids. And once that happened, it went to shift inhibit, and that's all that was wrong with the vehicle. Basically, we cleaned the screen out, put it back in, put the valve body back, and down the road it went. While we're here, I'd like to mention what you see in the red square box on the legend is the E shift valve. This shift valve seems to want to hang up even if just the wind's right. There are tools in the aftermarket you can purchase to go in and kind of clean up the bore. I've had guys tell me that that valve wasn't sticking when it came in. All they did was take the tail housing off a two-wheel drive to fix a rear seal leak, put it back together, and the valve would start hanging. Like I mentioned before, it's real important to keep these valve bodies clean, torqued right, and flat sanded. The tool that I was mentioning before has a threaded end for a slide hammer. I've actually tried to use the tool without the slide hammer, and it's a real bear to get it in there and get it back out. So it's a good suggestion to go ahead and get it attached to the end of a slide hammer. This is the 2010 to 2011 updates. As you can see here, everything that's shaded in yellow is what's been changed. Some of the major changes I just want to point out real quick is the main pop-up valve removed from the cooler bypass, increase in gain control for the clutch capacity when it's cold. All the stuff in gray is still the same as 2009 and back. We're going to kind of go over real quick on what can interchange and what cannot be interchanged. In the charts that you have listed in your handout, you'll notice next to where on the right column you'll see back serviceable to 2006. Now some of these yeses and nos will have 2 asterisks next to it. If you see that it says no, you can still check with Allison, an Allison distributor, before ordering the parts, because if you're working on an 09 and you want to try to put these later parts or go from early to late, you're really taking a big chance with this transmission. And we're going to talk about one of the major things that they're doing in here is they're downsizing the lube orifices. So if we start interchanging parts and we'd upset that lube, it could cause some serious damage to some hard parts in here. The ones with a single asterisk next to them, not recommended by Allison. Allison flat out says that that shouldn't be done that way. But you could possibly interchange it with some associated parts, or maybe as a complete package. Same thing here with the 3 asterisks. They may not be serviced back as an individual part, may include another part along with it, or another component as a package. So it is possible to back service some of these parts, or I wouldn't go with earlier parts into a later unit. Obviously, if it has no asterisk next to it, if it's no, it's no. If it's yes, it's yes. There's no chance of back servicing these parts with anything earlier. Here's what makes me nervous with this transmission. The engineers got together and decided if they downsized the lube orifice and restricted some of the lube to the parts, it would take drag off the transmission. This was done strictly for fuel economy. I don't think it's a great idea. Obviously, on paper, the engineers have actually figured that it will save some fuel. It may not be a lot, but they need everything they can get out of the vehicle as far as fuel economy. So this is one of the engineered changes that they've done to this. Again, here's the main shaft we're looking at coming into the trans, and this is the lube orifice that goes up to the clutch pack. So if they downsize that, less drag on the transmission when the vehicle's moving, and it saves fuel. This is the C1, C2 clutch housing, and you can see they've done the same thing here. We give you the updated part number, and we also show you what's included as far as other part numbers that go along with this. This will back service previous models. So you have all that information in your handout material. This is the updated shaft. This is what they, this is what they call the ground sleeve and bushing. We refer to it as a stator support shaft. We give you the part numbers of what can be changed and can't with this. Also, you'll notice on the 2010 and later, they went to a double friction clutch for TCC operation, and they've actually changed the one-way roller clutch in there. Instead of a sprag, they're using a one-way roller clutch. That also improves durability of the converter. This converter is not designed to back service anything previous to it. One of the other things you can do if you're trying to ID the converter, in between the converter pads themselves, you'll see some swedge marks on the outside. So that's the easiest way to do that. Okay, Dave is posting a comment here. The bore tool that I was talking about for the valve body, if you guys want to write it down, that's up to you. The one he has is from Sonax, and the number for the tool is 37000-02, B as in boy, S as in Sam, T as in tool. So that's the bore sizing tool from Sonax. Thank you, Dick. As you can see here, 2010 and later, there's some serious changes to the valve body, the solenoids, the complete hydraulic chains. None of this is going to retrofit back. So you have a complete list of everything that's been changed here in the valve body. This is what a 2010 and later valve body looks like up to 2013. We now have 3 accumulators instead of 2 that we had previously. And on the right, you'll see that they've added 2 brackets to hold the solenoids in place. And they have these 2 check ball capsules added where the actual trim solenoids or pressure control solenoids actually work. And a closer look at that, you can see here that the check ball capsules actually prevent feedback pressure going above control pressure. So once the valve works to where it has to, that pressure is held at where it's at, and they don't have to worry about any backfeed there. Like I said before, the solenoids remain the same. They're called pressure control solenoids, and this is all to help control the shifts and holding pressure once the shift has actually been made. This is a layout of the 2010 to 13 shift valve body. We have all the spring dimensions in there for you and the valve ID. Again, mentioning the bracket that holds the main modulating solenoid. Make sure that that bracket extension actually faces down. This is a list of the latest updated spring dimensions for that valve body. You have the part number, the number of coils, the actual dimensions of each spring is in there. Oil pump updates. One of the first updates that we saw was they changed all the springs. They've had a lot of problems, especially with that lube spring. We've had that spring break, collapse, and once that happens, we've actually had no movement out of the transmission at all. The other thing that you will see that the pump bushing has an orange color to it. These were some of the first changes that we've seen happen to this. Again, all this was done to address issues with engagement problems and also with pump line. These are the 3 different pump designs that you'll find. The one on the right is the latest and greatest. But I do want to mention one thing here. If you buy the latest pump, you can see the part numbers there, and the box on the left shows the part number on the box. Several guys have told me that when they went to purchase the latest one, that someone at the dealership basically took that sticker and put it over an earlier design. So before you pay for it, open the box, count the inner and outer teeth on the pump gears, just to make sure that you're getting what you're paying for. Some guys have actually paid for it. The driver leaves. They open it up only to find out that the tooth count is the same as the second design and the first design, and it's not an updated pump. A lot of issues with codes being set, shift errors, engagement complaints, and all this is being caused by electrostatic discharge, or ESD. Again, we can have the same complaints with electromagnetic interference, or EMI. On this particular vehicle that we were dealing with, it had a Goodyear Gatorback, which is an aftermarket belt. And the belt was actually made with some metal fragments in it. Just the rotating the belt around, the serpentine belt going around all the parts, was actually causing ESD. When going back with even with a stock one, if you have a stock belt on the transmission, on the engine rather, and you're still having problems with EMI, as you can see in the picture in the bottom right, we've actually had to remove the TCM from where it's actually located, which is usually down here in this section right near the front of the engine. We relocated it to the top of the UBEC, which is the underhood bus electrical center, and getting it away from the alternator, getting it away from the belt and all the turning parts in the front, attaching it to that UBEC cover was the only way we could actually stop some of the EMI issues that we were having with one particular vehicle. Several guys are doing this now. They're automatically moving it away from the front of the engine. This is a big problem that we see quite a bit. I mentioned before that these are work vehicles. They're construction sites, off-road. Not to say that a lot of guys in the aftermarket like to put chips in the computer to get more torque out of the engine. Now, these engines at the factory are detuned. They're actually keeping the torque down because the transmission can only handle so much torque. Obviously, the engine can put out way more torque than the transmission can take. This is just, what we're seeing here is just a stock engine with a stock transmission, no aftermarket chips added, and you can see that the stator shaft is actually twisted like the one on the right. Now that causes flow problems through the converter. We end up with a P0741 for a TCC slip, and usually when I get a slip code on a converter, it generates a lot of heat, and then that will be followed by a P0218 for trans temp being high. So this is a good thing to look at. Obviously you can see on the right before you even pull it out, the hole has to line up with that notch in the pump body. And if you already have it apart, you can see that this hole should also line up with that notch in the stator support itself. If you get one in your shop and it looks like this, it's very likely that someone has chipped it, and they may even be able to go back into the TCM and remove the software before they bring it back under warranty. You have to be careful because a lot of guys out there are buying this aftermarket stuff. They get the tool and they can change the torque, go out mudding with it, bring it back broken, and then claim it under warranty with you. One of the things you can do if you find it like a clean break like this one, if you have a scan tool that's capable of giving you all this data that you see here on the right, you'll notice it'll say max trans calculated engine torque. If you see numbers that high and that shaft is broken, it's very, very, very likely that it was overpowered. A lot of times we'll find the shaft actually broken the long way. If we see it broken that way or a crack in it, obviously that could just be material flaw or just over time being worked as a heavy-duty work vehicle. We've talked a lot in the past about fifth gear and, of course, now sixth gear errors on 2006 and up being associated with the shift fork and the sleeve, as you see here. Obviously, issues with the transfer case wearing. We have this clip that can help prevent that with a pump ride that actually starts to wear the transfer case. We've discussed this before in the past, but what I would like to mention now is we're seeing a lot more problems in the back half of the transfer case. Now this, you can see, this is where the output speed sensor goes, right in this hole here. Now if you get one in, what you'll probably find is this snap ring groove right here will be worn out. Now this allows that back half of the drivetrain to move back and forth. Obviously if it moves enough or it upsets the output speed signal, we're going to have ratio codes, may even fall out of gear or neutral out when you're going down the highway. One of the other things I want to mention, we're seeing more and more now, the actual bore where the bearing is held. We're seeing that bore wearing out tremendously. Guys have actually gone and replaced the back half of the transfer case, only to find it come back a few months later with the same issue. If you do have one where the bore is actually worn out, you need to go to the front of the transfer case. You'll more than likely find that the bore of that bearing up front is starting to wear also. It may not look nearly as bad as the back half, but if you don't fix the case problem in the front, it'll just repeat the case problem in the back. Obviously, the drivetrain's not being held center, and it puts more load on the backside, and that starts to wear out a little bit quicker. Well, that's it for today's presentation. Again, I want to thank Seal Aftermarket Products, and I want to thank all you guys out there for sitting in with me today. I appreciate it. I hope I see you guys at the next webinar. If you have any questions, do me a favor and just click on the little hand by your name. That tells me that you're actually texting something in so that I don't close out the webinar too soon. Okay, good question. I've got a question from Craig. He's saying he did not receive the handout material for this webinar. Okay, what you could do is at the beginning of your presentation, you can either email there or you can email me personally. I will make sure that you get it. My email is msou, Z as in zebra, @atra.com. Now I want to show you one of the things that we've been getting a lot of questions about the handout material. When you receive this email invitation that you see here on the screen, you should have received this, and when you did, you can see here that if you want the Adobe file of the handout material, you just basically click here and get the presentation downloaded right onto your computer. So the next time you receive this email, that's one of the first things you want to do is go ahead and click on that. It'll download the PDF for you, and then you can go ahead and register in the time zone that you want for the next webinar. Now while you're at it, to keep receiving this email without having to be invited, just go ahead and join our mailing list right here at the bottom left side. Click on that. It'll add your email in. These will automatically be sent to you as the webinars come out. And as each one comes out, just basically click on that red word here, and you can get the handout material. One comment made by Robert was he feels that the link should be sent with the confirmation email, not the seminar announcement. I have no control over that. The people that put this together thought it out the way that they should, the way they want it to be done. I agree that it would seem that once you're ready to actually attend the webinar, maybe it's a change that we'll add in later on. For now, the problem that I'm having is a lot of guys not getting the handout material, because when they get this registration email, they don't click on that word here and get the handout before they actually register for the webinar. But I will mention that to the guys at the office and see if we can maybe get that changed. One of the other things you can do is, you can see here on the right, if you want to, you can actually send this email to a friend. And I would appreciate it if you did. We can get more guys to actually attend the webinar. It is free, and there's nothing better than free. So if you want to send this to some guys that you know out there that would enjoy sitting in and getting the handout material, it would be a good idea to go ahead and click on that. All right, any other questions? Please click on the hand next to your name so I have an idea that you're actually typing in. Okay, I want to thank you all again for attending. I appreciate your participation. I appreciate you guys sitting in and watching our webinars. So I hope I see you in 2 weeks. The next one we'll be doing will be in 2 weeks from today, and it will be on Honda reprogramming. So that's the next webinar coming up. Thanks again, guys, and see you next time. So I see Rick's typing in a question. Rick, I see your hand is up. I'll hold out a little bit longer for you. Okay, I guess there's no more questions. Thanks again, guys. See you in 2 weeks. Rick, your question was, have you found park neutral position switch logic to always be the same? I don't quite understand what you're referring to, always being the same. You're talking about the slide that shows the internal mode switch? I think if the logic is not changing with the shifter movement, it sounds to me like we have either a wiring problem or we found a problem with the switch itself. Oh, you're saying that you found on a 2001, was it an aftermarket scan tool that you were using, or was it an OE scan tool? Because the chart that I show for all those model years is the same. Maybe the scan tool data didn't match the chart, but if there was no problem with the switch function or the transmission operation, I'd have to say that it might just be the scan tool data that you're actually looking at. Oh, okay, so it was an aftermarket scan tool. Sometimes I'll see data that doesn't make sense on an aftermarket scan tool, and I kind of just disregard it, especially like in this situation where you were working on an 01. The transmission's working properly. Like I said before, the data just didn't seem to match the chart for the switch. But if I'm not getting a code for it, transmission's working fine. No problems with backup lights, starting, anything like that. I would just disregard what I see on the scan tool. It may just be a data glitch with that software on the scan tool for that particular model year. Okay, you're welcome, guys, and I hope to see you in 2 weeks. Thank you again.